Good morning, everyone. Stephen here. How are you? Welcome to a inaugural screencast on the economics, microeconomics for the term. My usual proclivity for big chunky phrases is evident here. We're going to talk a little bit today about price elasticity of demand. What is that, you wonder? No. What we're going to talk about today, a little bit of a review on supply and demand. We're going to check in on some of the characteristics and curves associated with elasticity, some of the implications, and then we're going to just review those a bit. So pretty simple, straightforward. It's going to take us a moment or two to get into the meat. So here we go. So basic supply and demand. This stuff should basically be your friend or your enemy, but at least known to you at this point. These curves are considered to be concave upward, and that's actually a fairly intuitive shape, this concavity of demand, assuming that at a very high price, demand will be pretty low. These are very idealized. There is no demand curve that actually looks like this. Typically, when we talk about demand curves in the broader context, it's about total market demand. An individual firm may have a demand curve over time, which would be a graph that's really a series of dots of measurements about how much was demanded on each day or each week or each month over a period of time. So that's a more realistic use of demand in that respect. But we're going to be talking about economics. We're going to be very idealized. I'm going to set some of the context around this conversation in economics. And like all models, they're very useful, but they're also inaccurate, period. It's a lot like what Ted was talking about in the last webinar, where he spoke to his love of theory and his awareness of how it breaks down in the application of real-world issues. So what we're going to do tonight is to talk a little bit about elasticity and some of its implications and use those as a guidepost to making decisions as you go forward in business, having some model to come from, and then to make a distinct judgment in the face of a particular problem is one of the skills that we ultimately want to take you to. So, models, though flawed, are very useful. And this is to remind us that anytime we're speaking in terms of economics, we're working under the constraints of perfect competition. I like the case of these apples, which surprisingly not just are similar because they are clones, they are in fact genetically identical copies of one another. So that may hit the identical products in a little bit of a surprising way. Additionally, we know that firms have no market power, that there are no major barriers to entry and exit, and that everybody has perfect information of the marketplace, both buyers and sellers, in terms of knowing everything there is to know about the product, as well as all of the prices that the product is available for in a given marketplace. And then this idea here, ceteris paribus, we may have mentioned before, and it's a Latin term that also is a stage-setting piece for economics, which means that everything is being held constant except for the couple of variables that we're talking about. And when we're dealing with something as big and intense as an economy, or even a subset of the economy, there's so many variables in play that to even make this conversation have any meaning, we're just going to assume that all those variables are held constant with the exception of the handful that we're talking about. On this slide, we have a revenue equation, pretty simple, composed of two pieces. Those are price and quantity, P equals Q. Simply stated, this is the price that you charge per item and the number of items that you sell, be they a good or a service. Now, really any business, but specifically startup businesses, will be focusing on revenue and how to increase that revenue to get them up to a scale that is economically sustainable. Now, when faced with the question of how do I get more revenue, common response is to say, let's just sell more, and that makes perfect sense. But there's another consideration in this equation, which is price and what do we do with our price. So it's pretty clear from these two components that if you increase price, you'll likely also increase revenue. So the question that elasticity seeks to answer is, what is the price sensitivity with respect to the quantity demanded of a given good? Now, given the constraints of perfect competition, we know that if you increase the price above market level, you will result in selling zero. If you decrease the price below market level, you will sell all. Now, in the real marketplace, there's a range of prices for any given good in which buyers are willing to buy and sellers are willing to sell. So the question becomes, what is the price sensitivity in my category? And ultimately, what we're after is answering this simple question down here: how will a change in price affect the quantity demanded? It can be pretty easily shown that if the increase in price here is larger than the decrease in quantity here, you'll be left with a corollary piece, which is an increase in revenue. So that may be a situation that we're after. Let's explore elasticity a little bit further. Now here we are back to our idealized demand curve, and you can see three red bars here demonstrating different types of elasticity. Now the effect in question has to do with the relationship, the sensitivity between a given price and the quantity demanded. Now, if we were to lower our price, in this case significantly, we see that that would produce a very small change in the quantity demanded. This is referred to as being inelastic. Now, to the bar on the far end, we see from a given price level, if we decrease that price just a bit, it produces a change in quantity that is relatively large. We call goods and services, products essentially, with this behavior, we call them elastic, or consider them to be highly elastic. Now, as you might guess, the bar in the middle has a behavior that's something between both of them. So we'll look at a price, consider decreasing it, and we see, assuming I had drawn a straight line, that the relationship between the change in price and the change in quantity is equal. This is something we refer to as a property of unit elasticity, meaning that it has a one-to-one relationship. So in the calculation sense, the elasticity equals 1. Of course, all of these effects go in both directions. Either a price decrease, as I've modeled here, but a similar thing would happen in a price increase, which would be a shrinking of quantity. So here we're looking at three basic types of elasticity. We talked about something being unit elastic, where the change in quantity sold relative to a change in price is equal to 1. That is, they have a one-to-one relationship. An inelastic good is one where the relationship of the change in quantity to the change in price is less than 1. That is to say, we have a relationship that might look something like this: a small change in quantity to a large change in price. When something is elastic, which is probably the case in a lot of goods in the world that we'll be dealing with, and the elastic portion of this curve has a relatively flat-looking line, and slope is a good intuitive measure of elasticity as a guide to understanding it, but it is not actually considered to be an accurate measure. At any rate, in the case of something that is elastic, the measure of elasticity is always going to be greater than 1. Now, it's the convention in measures of elasticity to look at them as absolute values. That is, if you were to actually process the calculation, you would discover that the vast majority of elasticities are negative. By putting them through the absolute value, we're really just looking at the magnitude of the elasticity rather than the sign. The sign tends to confuse and doesn't really add to the understanding, so just know that the general convention is elasticities through absolute values, so they show up positive. And oops, I see that I made a mistake here. I said the correct words, which was that the measure of an inelastic good is less than 1. So they look like this. And there is a box in the text which gives you the full mathematical explanation, which I'd be happy to chat about at another time. So we've just described 3 primary types of elasticity, but I'm actually here to tell you there's 5. 2 additional types of elasticity are the fully abstracted ideas of something which is perfectly elastic and something which is perfectly inelastic. Characteristics of something which is perfectly elastic would show with an elasticity measure of infinity. This would be equivalent to this horizontal line. And the meaning of this is that changing your price will result in an absolute change in quantity. That is to say, if we consider the constraints of perfect competition, the moment you increase your price above the market price, you will sell 0. Something that is perfectly elastic would be represented by the perfectly vertical line, and it would have an elasticity equal to 0. And what this is saying is that you will sell a specific quantity, let's just put it there, and there is absolutely no impact of price on the quantity that you sell. That is, you could raise it or lower it to any level that you wish, and you will sell exactly the same quantity as always. And again, to contrast that with something that's perfectly elastic, the tiniest change in price will have an extraordinary impact on the quantity that you sell. These are, of course, very hypothetical, but nonetheless, these show up as being types of elasticity in your book, so I thought I'd give them another round here. That is your lesson today on price elasticity of demand. Next week's lesson we'll be talking again about this because there's some chunky bits in this that maybe are a little counterintuitive at first, and we'll cover a little bit of this and then go into elasticity of supply, and we'll talk a little bit about how to think about effects on that side of the equation. Tonight we looked at the revenue equation, which is price times quantity equals revenue. We talked a little bit about how it's similar to slope and that that's a useful way to think about it, but it's not exactly slope, so be conscious of that. It has 3 essential qualities, and this is for next week. I hope this was useful. Feel free to shoot any questions directly to me, and have a good day.